A solution looking for a problem. This is how the laser was described in the 1960s. Fast forward to 2026 and lasers are everywhere, from medicine to industry and even concerts. We are surrounded by them without even noticing. A crucial step in the invention of laser was the discovery of the Schrödinger equation. It described how a particle behaves in a given environment. This equation showed that an atom can only have discrete energy levels. But let's break it down. In an atom, when an electron rotates around the nucleus, it needs some energy. The farther it is, more energy is needed. Surprisingly, the Schrödinger equation predicts that not all the energies are allowed. That is why atoms have an energy level structure, in which the lowest level is called the ground state, while the others are called excited states. But how does an atom pass from one level to another? Thanks to the energy carried by the particles of light. Photons. If a photon passes close to an atom, it can be absorbed, and then the atom becomes excited. However, nature tends to minimize the energy, so an excited atom will eventually emit a photon and return to its ground state. This second effect is called emission, and it is exploited in lasers. Indeed, laser is an acronym: light amplification by stimulated emission of radiation, where radiation is simply another word for light. The basic principle of a laser is to go from a single photon to an enormous number of photons, up to a quadrillion, even in low-power lasers. To achieve this, many excited atoms are placed between two mirrors, one totally reflective and one partially reflective. This allows to direct all emitted photons into a single beam. From experience, we know that lasers can have different colors. But why? The reason lies in energy level structure. Depending on the distance between two levels, the emitted photon will have a different color. So what began as a physical speculation turns out to be a technology we now rely in many areas of everyday life.